Hello everyone. So next we are discussing about the fourth module continuation part. So that is serial communication. So within the serial communication already we are discussed regarding the transmitting of the data. So now we are going to discuss regarding the receiving of the data. So in case of the 8051, so if you want to receive the data from external devices to your microcontroller, so these are the 10 steps which you have to be followed. So first step what you can see is T mode register is loaded with a value of 20H indicating the user of timer 1 in mode 2, that is 8-bit auto reload to set baud rate. So in case of this one we know like T mode has to be first set, so that we need to decide in which timer is going to work and which mode it is going to operate. So when you set T mode to 20H, so it is going to work in a timer 1 mode. So when you set it for 01, so it is going to work in a timer 0 mode. So since it has been set for 20H, it is going to work in a timer 1, and it is also working in a mode 2 operation. So mode 2 is a 8-bit auto relay mode. Then TH1 is loaded with the set baud rate. So TH1 is loaded with a certain baud rate value, like we have know. So when you want to have the communication from microcontroller to some computer system, you need to have certain baud rate, that is number of bits you are transmitting, that has to be decided. So that the baud rate will be decided through this TH1 register. So TH1 register will be loaded with a different value like -3. So -3 is for 9600 baud rate. So -3, -6, like that we have different baud rates for different baud rate values for different baud rates. Like -6 is for the 4800. So like that we have the different values, so which will decide the different baud rates. So then the SCON register is loaded with the value of 50H. So this 50H is going to indicate what kind of the transmission is going to happen. As I told in previous also we have discussed, there are different what you can say is modes we have. So if you can look into this table, so you can see here SM0, SM1. So this one SM0 and SM1 is loaded with 01, so it is going to take you to the serial mode 1 and 8-bit data. One start bit is going to consider. So that's what it is mentioned here. So that is we need to consider as 50H. So here also in this table also it has been decided. So 01, 01 in the sense, 50H in the sense 01, 01 and 0000, all those things are 0. So here 01, 01 in the sense it is going to take you to for the mode 1, as it is discussed, that is it is going to take you for the this mode 8-bit data mode, where it is having the one start bit and one stop bit, and REN1 in the sense it can receive the data. So that's what it is how it is going to set. We are going to set the 50H for the SCON indicating serial mode 1, where an 8-bit data and one start bit and one stop bit is mentioned. Then TR1 is set to 1 to start the timer. So we know we are using the timer 1 in the sense we need to if you want to start the timer, we need to set the TR1 in the SCON register. We need to set the TR1 register so that it can start the timer. So once you if you want to stop the timer, you need to clear this TR1 register. Then the execution of this timer is controlled through this TI flag. So TI is continuously observing the whether how much value it is getting updated on your this TH1 register. So once it reaches the maximum value, then TI is going to be it is going to be high. Then it is to be like it has to be made clear so that it can take you for the further timer operations. So already like at the initial stage TI has to be cleared, so that once it reaches to maximum value, then only it is going to made high. So automatically TI is going to update to 1, right? So that's why before is execution you need to clear it. Then the character byte to be transferred serially is written into the SPUB register. So the data which you want to transfer to the external peripherals, that data has to be taken into SPUB register. Then TI flag is a bit is monitored with the use of the instruction GNV TI, access to see if the character has to be transferred completely. So here in this case TI is going to be kept in this loop, that is XX JNV TI XX, in the sense this will be there in the loop until it goes high. So it is going to transfer all the data from that is, it is going to take all the data from the SBUF register to some external if you are assigning some accumulator, that there it is taken all the bits of the what you can say SBUF register. So to transfer the next byte, go to step 5. So if you want to repeat the steps, you need to go from this step 5 and it is going to repeat it. So next is about a program. So we are going to see one program for the receiving some datas, like we are going to see program here, like it is written, write a program for the 8051 to transfer a letter A serially at 4800 baud rate continuously. So this is we are going to send a character with this much baud rate, that is 48,800. So move t mode comma 20h. In the sense, it is going to set timer 1 in the mode 2 and it is going to take you into the auto reload mode. Then move th1 comma -6. In the sense, my th1 is loaded to -6. In the sense, it is going to set the baud rate of 4800. Then move s comma 50h. So we know scon is loaded to 50h. In the sense, it is selecting the mode where it is having the 8-bit data, 1 start bit and 1 stop bit. Then REN is enabled. Then set B tr1, in the sense it is going to start the timer. Then move sbub comma a, that is sbub is loaded with the character A. Then whatever the character A is having, in the sense the ASCII value of the character A is loaded into sbub, and the continuously it is observed that all the bits of the A character is transferred to the sbub through this instruction, that is JNBTI here, JNBTI comma here. In the sense, it is continuously in the loop, so that all the bits of the A character will be taken into sbub register. Then once the totally A character is loaded into sbub register, then we are going to clear the TI. So once it is all the bits of the A character is loaded, so it is going to high, then it is going to come out, and again we need to clear it so that we can go for some other characters. So here I am speaking the bits of the character. Bits of the character, in the sense, always we know, like each of the characters, each of the letter is having certain ASCII value. So that ASCII value will be having the bit patterns. Like if suppose I have value as 50h, so 50h is having as 0101 and all zeros. So this is a bit pattern, 8-bit pattern we have. So this 8 bits has to be loaded into the sbub register continuously. So once all the bits will be loaded, then it is going to be high, so that it is indicating that all the bits of this particular character are loaded, and we can proceed with the next thing. So this is how this program is going to execute. So next is about a program. So here, write a program for the 8051 to transfer S serially at 9600 baud rate 8-bit data 1 stop bit to this continuously. So here also they have indicated a set of characters, that is YES. This character, this string we are going to transfer with a 9600 baud rate. So move t mode comma 20h. In the sense, we are going to select the timer 1 in mode 2 with auto reload mode. Then move th1 comma minus immediate data -3. So this is -3, it is not -3h, it is -3. So it is -3, in the sense it is selecting the 9600 baud rate. Then move scon comma 50h. So scon is loaded with the 50h, in the sense it is going to select the mode where we are having the 8-bit data, 1 start bit and 1 stop bit, and it is enabling the REN. Then we are going to start the timer using SCTB tr1, set B tr1. We are starting the timer. Then first character we have taken into accumulator, move a comma #y. So first character we have taken. Then call trans. So here we are calling this trans program. So here you can see. So move sbub comma a. So accumulator is loaded with the first character. So sorry, sbub is loaded with the first character. Then it is continuously observed each of the bits of the particular character is loaded or not. It is continuously observed through this TI. Once it has been done, then it is going to return to the next instruction, that is move a comma #e. That is, it is going to load with second character E. Then again call trans, and again it is going to observe that all the bits of the E character will be loaded into SBUF. And again you are going to once it is executed RET, it is going to go for the next instruction, that is move A comma hash S. So here it is going to call trans, in the sense again we are going to execute this. So all the bits of the S character will be loaded successfully into the SBUF register. Once it is loaded, again we are going to go for this, and it is going to execute continuously. So this is how this program is going to be executed. So next is about, so it is about a program where we are actually going to see how we are going to receive the data. So you can see the program. Write a program for the 8051 to receive bytes of data serially and put them into P1. Set the baud rate at 4800, 8-bit data, and one stop it. So this is the description. We are going to see how it is going to work. Move T mode 20H. So move T mode 20H, in the sense we are selecting the timer 1, then 8-bit auto reload mode, and it is next having the instruction as move TH1 comma hash -6. Hash -6, in the sense we are selecting the for 4800 baud rate. Then move S comma 50H, in the sense we are doing the same thing, like 8-bit data, one start bit, one stop bit, REN enabled we are doing. Then set B TR1, so it is going to start the timer. Then JNB RI comma here, so continuously we are going to observe this RI bit. So this bit is for to wait is for where we are going to have all the bits of the particular value or the character with whatever been sent from the external, and which is loaded into the SBUF register. So continuously we are going to look into this, so until it is going to get high. So it will be there in the loop until it is high. So if it is 0, it is there in loop. If it goes high, then we are going to come out of that. So it means that SBUF is loaded with the character. Then whatever the character it is loaded onto SBUF, it is taken into accumulator. Then the character it is taken from the accumulator is loaded to P1. So then again we are going to clear the array register. So clear the array register, in the sense we are ready for the next character to be received. So this is how the program is going to be executed. So next is about, it is about how we are going to increase the speed of communication. So if you want to increase the speed of communication, you need to increase the baud rate. So there are two ways to increase the baud rate. One way is like you can increase the frequency, but since the system frequencies, crystal frequencies is fixed, so we cannot vary that one. So to use higher frequency, that is one method. Then second method is you use the PCON register. So PCON register is an 8-bit register. So when you are using it, so S mode is 0 at that time. When you are going to use when you are using this PCON register, that time the baud rate will be doubled. So this is the PCON register which is mentioned. So here what will happen is, so here in this case, when usually what will happen is, whenever the S mode, whenever you power up, S mode is by default it will be 0. So if you want to increase the baud rate, you need to have this S mode to be 1. So how we are going to make this is move A comma PCON. So PCON, all the bits are going to be taken into accumulator. Since it is not bit accessible, so we need to take into accumulator. Then we are going to set accumulator 7th bit high. Then again we are going to read that accumulator into PCON register. So in this way we are going to make the S mode high. So once you make the S mode high, there will be changes. So you can see here. So oscillator frequency is 11.059 megahertz. Then machine cycle frequency is 921.6 kilohertz. Then in S mode 1 is equal to 0 and S mode is equal to 0 and S mode equal to 1. So what will be changes is it in case of S mode equal to 1, it is divided by 16, whereas in case of S is equal to 0, it is divided by 32. So obviously in this case the frequency is maximum. So you can see in the S mode is equal to 1, so what will be the baud rate? So obviously you can see, like in case of the S mode equal to 1, we have maximum baud rate, so through which we can achieve the maximum speed of the communication. So next we are going to see one example. So here it is assumed that XTL is 11.059 megahertz, that is clock frequency given for the following program. What is the program? What this program does: computes frequency used by the timer 1, set the baud rate, find the baud rate of the data transfer. So this is how some of the things been asked. So we are going to see first of all how this program is working. Move a comma pcon. So pcon's content will be taken to accumulator. Accumulator 7th bit, it is made high. Then move pcon comma a. So actually it is set to be accumulator 7th bit, so there has to be some correction. Then move pcon comma a. So accumulator content has to be taken into pcon register again. That is we have increased the s mode to 1. Then move t mode comma 20h. So we have selected the timer 1 and mode 2, so that's what we have loaded with the 20h. Then move th1 comma minus 3. So that is even it is loaded to the minus 3, so we have the baud rate of 19,200. And then move scon comma 50h. That is it is loaded with the 50h, in the sense 8-bit data, 1 stop bit, and REN is enabled. So here set b tr1, in the sense we are going to start the timer. Accumulator is loaded with the character b. Then we are going to clear this ti. Then sbuf is loaded with the accumulator's content, that is first character is taken, and continuously it is observed whether all the bits of the character will be loaded or not. So once it has been done, then sjump a1, in the sense it is going to clear the ti. So this is how this program is going to execute. So next we are going to see a program. So this program is written for to transfer a character y with a baud rate of 9600, and the description is given like this: write a program to transfer a letter y serially at 9600 baud continuously, and also to send letter n through port 0, which is connected to a display device. So there are two ports we are accessing, one is port 3 and port 0. So we are going to see how actually it is to be done. So it will start with the org00h. Then move t mode comma 20h, in the sense we are selecting the timer 1 and mode 2. Then move th1 comma minus 3, because we want to have the 9600 baud rate. Then move scon comma 50h, so that we have 8 bits 1 stop bit REN enabled. Then next is set tr1, so we have started the timer. Then move sbuf comma first character, that is we have taken y. Then all the characters of the y will be read here, all the bits of the character y will be read here. So once it is been done, then move p0 comma n, that is next character we have taken into p0, is jump again. So this is how it is going to work. So this is the working of this program. So next we are going to see one more program. So take a data in through port 0, 1, 2, one after another, and transfer this data serially continuously. So we are going to see how it is going to work. Move t mode comma 20h, that is it is going to design for the timer 1. Then mode 2, then th1 is loaded with the minus 6, in the sense it is going to load with the it is designed for the 4800 baud rate. scon is loaded 50h. Then p0 is loaded with ff, p1 is loaded with ff, p2 is loaded with ff. So they are loaded with the certain values on the port 0, port 1, port 2. Then set tr1. So actually what they are making is port 0, port 1 and port 2, they are taking some data, so that's why they are made take data through port 0, port 1, port 2. That's why they have sent ff to all these 3 ports. Then set b tr1, and since we are going to start the timer, move a comma p0. So first data we are going to read from the p0 port, then a call send. So it is going to read it is going to call this send program, that is move sbuf comma a. So accumulator's content will be loaded with the sbuf through this instruction, that is here jnb ti comma here, then clear ti ret. So it is going to return for this instruction. Then move a comma p1, in the sense second value whatever it is coming from the p1, it will be read through this sub program again. Then again you have to call send. So that's what happened. And then move a comma p2. So again you are going to read the value from the p2. So again you for that again you need to call this call send, in the sense you need to call this program. So as you are calling this program, so whatever the values you are reading from the p2, p1, p0 will be taken to sbuf register. So this is how it's going to work. So next we are going to see one example. So here Port 0 of an 8051 is used to monitor a parameter in an industrial environment. If the parameter gives a reading above 0fh, a message high is to be sent serially, otherwise a message OK is to be sent. The words high and OK are burdened to the program ROM. So this is the description given. So what we need to do is we need to continuously check a port. So that port, that is port 0, we need to check, and if the parameter gives reading above 0fh, so the port value is above 0fh, then we need to send high, otherwise we need to send the OK message, and both this high and OK message has to be there on some ROM location. So we are going to see how this program is going to work. So org00h, in the sense we are starting the program from 0 location, then move p0 comma ffh. So this is the value with which we want to compare. So it has to be loaded the p0 is loaded the 0ffh, in the sense we are making this as an input port. Then move t mode comma 20h. So t mode is loaded with the 20h, in the sense we are going to make use of the timer 1 for the mode 2. Then move th1 comma -3, in the sense we are setting with the baud rate of 9600, and move scon comma 50h, in the sense we are selecting 8-bit data and 1 stop bit REN enabled like this. Then set b tr1, in the sense we are starting the timer. Then move a comma p0, so we are reading the value from the port 0, and that will be loaded into accumulator. Then it is compared here, compare jump not equal a comma 0fh test. So here it is going to be compared, the accumulator, whatever the content we are getting from the p0, it will be there on this accumulator. So both will be compared. So if it is equal or not, it will be compared here. So if it is both are not equal, then it is going to jump to this test. So here it is going to jump. So on this test, it is going to check whether it is generating any carry or not. So it is if it is not generating any carry, in the sense the accumulator content is maximum. So whatever the value we have obtained on this accumulator content, that will be maximum, that this 0fh. So for that, what the condition they have given. So if the parameter gives the reading above 0fh, in the sense what we need to do, we need to print message high. So we now for this condition we need to print the message, high now. So we are going to see how it is going to work. So jump now carry. So if it is not generating any carry, in the sense accumulator content is more, in the sense we need to jump to where high. So here it is going to come. So move dptr comma 0090h. So we are going to see what is there on 0090h. So we can see here, right? So on the 0090h, so you can see we have a variable called mes1. So mes1 colon db high. So this define byte. So this mes1 is a variable that will be defined with a byte of this high character. So this is a high string, so that will be assigned to mes1. So whenever the mes come, wherever the mes comes, so that will be replaced by this high. So this is just like equalization. So it is a on the 0090h location we are loaded with a high value. So next is, after this what we have is move dptr comma 0090h. So after that our call access. So our call access, in the sense we are calling the program access. So here you can have this access program. So here in this case first is clear a, accumulator content is cleared. Move c comma a at a plus dptr. So we are going to access the at dptr's content. So dptr is having right now this high value. So first character we are reading in this accumulator, that is here. Then a call send. So a call send, in the sense we are calling this send program. So here we are coming now. Move sbuff comma a. So accumulator's contents, that is first character, that is h is taken into accumulator. Then this sbuff is loaded continuously through these instructions. We know already how it is going to execute. So once this executes the ret instruction, then again it is going to go for the next, that is inc dptr clear a, move c a comma at a plus dptr. In the sense we are going to read the next character using a call send. That is next character is what? It is I. So when you increment dptr, it will come to this. Now dptr is having this I character. So call send, in the sense again we are going to read the character I into sbuff using this all the instruction. So once it is executed, then it is going to come for the next jump check. In the sense again it is going to go for the previous. So you can see here, so yes, jump check, in the sense it is going to check the again some other values. So if suppose we have taken the first case, if suppose there is other case, that is it is not having it is having a carry, then it is not going to execute this one, then it is going to come for this instruction, that is move dptr, 00a0h. so on the 00a0h we can see what is the value we have. So on the 00a0h we have the value, that is message to db okay. So okay value, okay string we have, so that we are going to execute. So again call access, in the sense again we are going to call this, that is clear a, move a comma at a plus dptr, then at dptr, in the sense first character is o, that will be read how it is using the calls, and it is going to read here. Then increment dptr, in the sense it is going to come to the next character a, then that will be taken in through this send program, and it is going to execute using the return, it is going to execute the next any values that is coming to this. So this is how it is going to execute this program. So next is about